Hi students, let's look at this question A, which was actually taken from the year 2019 SAJC paper 2 question 10. This question is on what do you call it? Binomial distribution. Let's look at that. Okay, for part 4, you need to use this one. You need to use a bit of normal distribution, mean number, which is actually sampling. If you are stuck here, I may not have covered in class, so I have not covered in class yet lah. So just take note of that. Yes, so let's look at how we could do this question proficiently. For the first one, a factory manufactures a large number of erasers in a variety of colors. Each box erasers contains 36 randomly chosen erasers. On average, 20% of the erasers in the box are blue. So each box have 36. Say in context of two assumption modeled number of blue yada, to box to be well modeled by a binomial distribution. So basically, if you want to binomial, you have to state in context of the question. Okay, so the variety of colors, right? Each eraser, the chances of the color is independent of another. So means the chances of the eraser being blue is independent of another eraser being blue, and also there's a fixed number of erasers in the box, which is 36, and they are mutually exclusive events. So whether you are blue or not, okay. So you just stick in color in context of the question. So every eraser is equally likely to be blue. It's also okay. So it just means is random, okay. Yes, so that's about it. So I don't think I need to go through that go through this part here. We could just look at that, okay. So then the next part would be find probably that a randomly chosen box of eraser contain at most 6 blue erasers. So I'm just gonna name the blue eraser. So let x maybe you just let x be the number of blue erasers out of 36 erasers. Okay, just make sure you know how to define this properly, because many times students think that they can but they can't in exam. So please practice a bit. So this part here, right now in your assignment, so that I could mark them. Part 2, part 1 just refer to the one below. Okay, so chosen box eraser contain at most 6 blue. So basically x would be binomial 36, and we have 20% chance of each being blue. So find probably that at randomly chosen box of eraser contain at most 6 blue erasers. So probability of x at most 6. That's about it. Okay, so this is about it. Key in calculator should be okay. CDF. So this will be 36, and this is 0.2, and this is 6. So this is 0.40069, which is 0.4003 SF. Oh, 601. Oh, okay, 401. Sorry. There you go. There you go. Then the third one. So 200 randomly chosen boxes are packed into a carton. A carton is considered accepted if at least 40 of the boxes contain at most 6 blue erasers each. Carton is considered at most 6. Find probability that running. Right, so this is another probability within another probability lah. So what we're going to get is actually you choose one box, right? One box, the chance of at least 40 box contain at most 6 blue erasers, which is actually the chances from part 2. Okay, so if you think about it, this chance here, so this is quite a common question, which is what we did many times. So part 3 here, you just have to be clear. The boxes is, so I'm just going to let y be the number of boxes. The condition of the boxes which have at least 40, at least what? Which contain at most 6 blue erasers out of the 200 boxes. Okay, so the question now is your choice now is Y. This you have 200 boxes. Every one of it is px at most 6. Okay. Then you want at least 40% of it. So 200 times 40%. 80. Yeah, 80. Yeah, 80 lah, 80. 80 boxes. So you want py 40 of the boxes contain at least 40% of the boxes. So at least 80 boxes. Okay. This is how you define it. So basically this one here, remember this one put more than 3 SF is a cardinal sin to put just 3 SF. Don't do that, please. Don't do that. You don't do that. Just don't. So what we're gonna do is actually this is what we're gonna find. So this is at least 40%. At least 40%. So we know that calculator doesn't give us 80. So we need to take 1 minus py less than equals to 79. Working calculator 200. Yeah, we're coming to an end, man. Can't wait. X is 79. Hey, come on. 1 minus 0.465227 is 0.53477. 3 SF. It's okay. Then part 4. The carton are exported by sea. Over a 1 year period, there are 30 shipments of 150 carton each. Using a sort of find probably that the mean number of acceptable ship in the year is this one. Okay. So this is CLT, central limit theorem. The currently in the H2 math syllabus, the only approximation that you have, if I didn't recall wrongly, is your central limit theorem. Okay. Yeah. So if you are looking at mean number just means that you are looking at acceptable, because this is acceptable, right? You're looking at what this event here, which is acceptable. This one here, acceptable. Okay, but you need to name the new event. So acceptable, the chances probably of getting acceptable is this one here. This is acceptable. Okay, then you have every one carton. Is it not? Every one batch. Carton, okay. So every one carton has got a chance of 53.477% of being acceptable. So now you are asking, using a suitable approximation, find the mean number where acceptable shipment for the year is less than 80. Okay, so acceptable or not acceptable. So you have 30 shipments of 150 cartons over one period of time. That is for the year is less than 80. There are 30 ships, 150. Yeah, 150 cartons. So 150 carton, then the chance is whether it's acceptable or not. Okay, that is the thing. So you have got okay, great. So let's look at that. Let's see how we do that properly. 30 sheets with 150 carton each. Okay, great. So one shipment is 150 lah. One shipment is 150. Then one shipment is 150 carton. Yeah. Then you want to find the mean number. So I'll just do this straight. So we define another one, which is define the binomial distribution of the carton. The carton which whether you're acceptable or not. Okay, so let A be the number of cartons which are acceptable out of 150 boxes. cartons. Okay, so this is cartons. It's very, very confusing. Yeah, so this is acceptable. So this is acceptable or not? Just use acceptable lah, because it's acceptable, right? Yeah. So we number of cartons which are acceptable out of 150. So here with A means acceptable, binomial 150, and each of it, which is 0.53477. You can use more SF if you want, but I'm just going to use 5 SF because I didn't write more just now. Could have written more. So anyway, we look at this part here. So this one is for 1. So now you ship out 30 batches, you ship out for 150 carton, which is, yeah, this is one batch. So 30 shipments. Every one shipment constitute 150 cartons. Okay. Using a substitution rule, I'll find the probability that the mean number of acceptable cartons per shipment for the year is less than 80. Okay. So in other words, right, you are looking at the mean number of A. So the mean number of A is, you're looking at, you're finding A1 plus A2 plus all the way to A30, because you have 30 shipments. Every one shipment you have 150 cartons, so divided by 30. Okay, this is your mean number. Okay, understand this, huh? So you if you already learned in school, then you will understand this. But when you are doing sampling, we'll do more of this question here. So then the next part will be you because since n is large, okay, because the thing is, you can use binomial to solve this. It's not an issue, but the problem now is because it's using a suitable approximation, so you have to use central limit theorem. So n30 is large. So this is n equals to 30 is large. We by see our central limit theorem, just spell it out. Central limit theorem. We can write A prime as a normal distribution. Then basically, approximately. You just need to write the word approximately behind. Okay, so from here, expectation of A, we know is 150 times 0.53477. Expectation is also the mean, so we're just going to put here. Then we need to find the variance, which is also n times np, variance of A, 150 times 0.53477. That's 1 minus 0.53477. Okay, just key in calculator and you see whether you get the answer. So this is 0.5. Then this part here, I'm just going to multiply this with 1 minus. This is 37.3186. So this is 80.2159. This is 37.316. Okay. So this is by using the suitable approximation, which is central limit theorem. So from here, what we need is the mean number to be at most is less than 80, because this is already a continuous spectrum. Less than 80 is the same. So you just key in calculator, CDF, negative infinity to 80, using this formula here. Oh, sorry, this need to divide by variance 30. So variance A, this is var A over n for mean. Okay, you know that. Yeah, so then you key in calculator, you should get negative 10 to the power 99, and upper will be 80.2159 square root 37.3186 divided by, this would be 0.42325. This is probably one of the most confusing part in stats, which is central limit theorem. We use it quite often actually. Okay, so but other than that, I think it's fine. It's not like this part is a bit confusing, but you try and orientate it properly, and it will be okay if if you are able to understand the a shipment is 150 cartons, and you have 30 shipments in a year, and yeah, that's what you want to get. Right, so let's say part 5. Part 5 would be the owner decided to change the proportion of the blue erasers to P. A box of eraser is chosen. Okay. Write down in terms of P probability the box contains exactly one blue eraser. The probability that a box contains exactly one blue eraser twice is twice the probability of a box containing exactly two blue erasers. Okay, let's look at that. How do we do this? Okay, we are just going to define a new random variable. I don't know about you, but for me, when I define the random variable, at least I have a grasp of like how the thing are moving, right? So I already used what have I used? I used a xy. Okay, then I'll just use every question also need to define. So let k or p xy let n new be the number of blue eraser out of 36 erasers in the change. The new, maybe the new number of, yeah, after change. Okay, so basically because the definition is the same as x, so we might as well just name it differently. So we have n, which is, it stands for new binomial, when this is 36 and this is p lah. Now bear in mind p would be 0 between 0 and 1. Okay, so right now in terms of p, the probability that the box contains exactly one blue eraser, I think this is okay. In terms of p, exactly 1, p n equals to 1. One box is 35, right? So this one we know is 36 p power 1 minus p 35. So this will be 36 p 1 minus p 35. That's about it. So part 4, probability of the box contains exactly one blue eraser. Exactly one blue eraser is twice the probability that contains exactly two blue erasers. So probability of, so is one blue eraser is twice the probability of exactly 2. Okay, so we're just going to write it down and try and solve it. So this part here, Pn equals to 1 is 36. P1 minus P36. 35. This is 36 choose 2. Occurrence is P2. Non-occurrence is 34. 36 choose 2. 630. P square 1 minus P 4. Okay. Now what you do is you just kind of cancel, since you can cancel away the p because p is not 0, right? Now when you cancel, you have to know what you can cancel, because okay, fine. If you cancel away, you're cancelling away p equals to 0 is a root. So try not to cancel like that, but because this is not an equation, it's not a solution, since p is not equal to 0 and p equals to 1 not equals to 1, so you can just cancel as you wish. Okay, this is why you should know what you should cancel or not. So then this will be 60, quite easy. I think it's quite okay. I shouldn't use the word easy, huh? Easy is relative. 5 over 2. What, where? Easy my foot. What room? Oh crap. Easy my foot. Let's see. 36. Oh, P. Oh crap! I never put a 2. No wonder. Miss out the 2, man. Times 2. Okay. Doesn't make sense at all. It's twice. Oh, there's a P there. Yeah. See, cancel. Okay, 36, 1 minus P. 2360P. Yeah, you go. So there you go. So this will be 630 times 2. Easy, but don't get careless mistake like me. 1 minus P. 36P. Okay, there you go. That's about it. Any questions or comments, just let me know. Text me, get hold of me, ask me any question, okay? Keep practicing. I'll see you in the next video.